Students, come to next concept. After the maturity of gynoecium, it is the female reproductive part in a flower. After the maturity of that gynoecium, it is the part that is called as ovary. This part called as a style. It is a stigma. After the fertilization, after the maturity, the ovary is develops into fruit. Ovary develops into a fruit, and inside the ovary occurrence of ovules. Here the ovule after the fertilization, the ovule is develops into seed. After the fertilization, after the maturation, the ovules which are develops into seeds. Whole ovary is develops into fruit. Whole ovary is develops into fruit. Here what is that? Here fruit means the ripened ovary, matured ovary, fertilized ovary. The fertilized ovary is called as fertilized ovary is called fruit. Fertilized ovary or ripened ovary or matured ovary is called as a, what is that, fruit. Here the fruit usually covered by fruit wall. That fruit wall is called as pericarp. Here the fruit means matured ovary or fertilized ovary is called as fruit. In some cases, the fruit develops without fertilization. That kind of fruits usually called parthenocarpic fruits. Parthenocarpic fruit. Here parthenocarpic fruit means seedless fruits. The formation of fruit without fertilization, that kind of fruits are called as parthenocarpic. In general, the fertilized ovary is called as a fruit. Formation of fruit without fertilization, that is called as parthenocarpic fruit. Best example for that parthenocarpic fruit, banana fruit. Banana is the parthenocarpic fruit, that is seedless fruit. If the ovary is develops into a fruit, that is called as true fruit. True fruit means in a flower, ovary is develops into a fruit, that is called as a true fruit. In some cases, the fruit is develops from thalamus of the flower. Thalamus is develops into a fruit. That fruit is called as pseudo fruit or false fruit. The fruit is develops from the thalamus. Particularly in the case of apple, the apple is called as a false fruit. Mango is the true fruit. Banana is the parthenocarpic fruit. Usually, around that fruit, presence of protective wall of the fruit, that is called as pericarp. Protective layer of the fruit is called as a pericarp. Here the pericarp is differentiated into three layers. Fruit wall is called as a pericarp. Pericarp is differentiated into three layers. Outermost layer of the pericarp, that is called as epicarp. The second layer mesocarp, and the innermost layer, that is called as endocarp. These are the three layers of pericarp: epicarp, mesocarp, and endocarp. If the fruit containing all these layers, that kind of fruit usually called drupe. Drupe is the fruit. Three-layered fruit fruit. Here the pericarp is differentiated into epicarp, mesocarp and endocarp. That kind of fruits, the fruit containing all these three layers. Here the pericarp is differentiated into epicarp, mesocarp and endocarp. That kind of fruit, that is called as a drupe. That is called as a drupe. Best example for drupe, that is mango fruit. Mango fruit. Mango fruit is the best example in the case of mango fruit, where there is occurrence of all these three layers. Epicarp is the outermost leathery layer. Mesocarp in the case of mango. Mesocarp is the juicy layer, and endocarp is a hard or stony layer. All these three layers which are present in a fruit, that fruit is called as a drupe. Best example, mango and coconut. In the case of coconut also, where outermost layer, that is epicarp is leathery. In the case of coconut, mesocarp is fibrous and endocarp is very hard. In the case of mango fruit, the edible part is mesocarp. In the case of coconut, the edible part of the coconut, that is called as endosperm. Endosperm is the edible part of the coconut. Inside the endocarp, beneath to this endocarp, presence of a nutritive layer, that is called as endosperm. Here, for example, it is the fruit. Here outermost layer is leathery. It is mango fruit. It is the one-seeded fruit. It is seed. The outermost layer, that is called as epicarp. Second layer, juicy layer, that is called as mesocarp, and inner endocarp. In the case of this fruit, occurrence of three layers. Here the pericarp is differentiated into epicarp, mesocarp and endocarp. Therefore, this kind of fruit, that is called as a drupe. In the case of coconut, it is the, suppose it is the fruit. The outermost layer is the leathery. The second layer is the fibrous layer. It is the stony layer. It is epicarp. It is mesocarp. It is endocarp. Inside the endocarp, presence of nutritive layer, that is called as white kernel. That white kernel of the coconut fruit, that is called as endosperm. The endosperm is the edible part of the coconut. It is about the fruit. The fruit wall, protective layer of the fruit, that is called as a pericarp. Pericarp is differentiated into epicarp, mesocarp and endocarp. All these three layers which are present in a fruit, that fruit is called as a drupe. Suppose the endocarp is absent in a fruit. Only pericarp is differentiated into epicarp and mesocarp. A pericarp is differentiated into epicarp and mesocarp. Endocarp is absent. In this fruit, endocarp is absent. That kind of fruit is called as berry fruit. Berry means two-layered fruit. Here the pericarp is differentiated into two layers only, epicarp and mesocarp. A best example for berry, that is tomato fruit. In the case of tomato, outermost skin, outermost layer, outermost layer of the tomato, that is called as epicarp, and next to that layer, that is a edible part, that is juicy part, that is called as a mesocarp. Here in a fruit, only a two layers which are present, that kind of fruit is said to be, what is that, berry fruit. Suppose the pericarp is differentiated into only one layer, that is epicarp. Pericarp containing only that to be differentiated into only that epicarp, that kind of fruit, that is called as capsule. Capsule is the fruit, one layer of fruit. Where in this fruit, what is the pericarp is differentiated into only one layer, that is called as epicarp, that is called as a capsule. Best example for that capsule, that is chili fruit, lady's finger fruit, where pericarp is differentiated into only one layer, therefore the name is called as a capsule. The capsule is a one layered fruit, berry is a two layered fruit, drupe is three layered. Based on the nature of pericarp is the outermost layer of the fruit. Based on the nature of the fruit and pericarp, the fruits which are classified into dry fruits and fleshy fruits. Here the dry fruit means pericarp after the maturity, during the maturity of the fruit, pericarp dries up. That kind of fruit is called as a dry fruit. Suppose the pericarp remains fleshy. That kind of fruit is called as fleshy fruit. Best example for fleshy fruit are tomato fruit, mango fruits, which are the fleshy fruits. And date fruit is the dry fruit. Here, these are the major differences. Pericarp remains fleshy, that is called as a fleshy fruit. A pericarp dries up during its maturity, that is called as a dry fruit. These are the different types of fruits. And after the maturity of the ovary, the fruits which are developed after the maturity of the ovules, what is that? Seeds which are developed. Here the seed means fertilized ovule is called as a fruit. Ripened ovule is called as a fruit. In general, the seed is containing outermost layer of the seed, that is called as seed coat. Outermost protective layer of the seed, that is called as a seed coat. Internally, the seed containing embryo and endosperm. Here the seed coat is the protective layer of the seed. That seed coat is differentiated into two layers. The outermost seed coat, that is called as testa. Testa is the outermost layer of the seed coat, and second layer of the seed coat, that is called as tegmen. Testa and tegmen, which are the two layers of seed coat. Usually, inside the seed coat, occurrence of endosperm and embryo. Suppose the seed containing endosperm, seed with endosperm, that kind of seeds are called as, such kind of seeds are called as endospermic seeds. Endospermic seeds. See, in some cases Seed without endosperm. Seed without endosperm. Seed without endosperm. That kind of seed is called as seed without endosperm, called non-endospermic seed. Non-endospermic. Based on the presence or absence of endosperm. Endosperm is the nutritive tissue. That nutritive tissue provide nourishment to that embryo. Nutritive tissue provide nourishment to that embryo. That is called as endosperm. Endosperm is the nutritive layer. Suppose the seed containing endosperm, that kind of seeds are called as endospermic seeds or albuminous seeds. Albuminous seeds. Seed without a endosperm, that kind of seeds are called as non-endospermic seeds. Here usually majority cases the dicot seeds which are non-endospermic seeds, majority cases. In few cases, some of the dicot seeds which are also containing endosperm. Majority of the dicot seeds which are non-endospermic, because during the seed maturity, endosperm is utilized. Endosperm utilized during the seed maturity. That kind of seeds which are considered as non-endospermic seeds. The residual endosperm is present in the seed, especially in the case of monocots. Such kind of seeds are called as endospermic seeds. Come to the dicotyledonous seed. Dicotyledonous seeds. Majority of the dicotyledonous seeds which are non-endospermic seeds. Non-endospermic seeds are exalbuminous seeds. Absence of albumin or absence of endosperm. That kind of seeds are called as non-endospermic seeds. All the majority of the dicotyledonous seeds which are endospermic seeds, except to that of a castor. In the case of castor seed, presence of a rich endosperm is present. Particularly in the case of dicotyledonous seed. Dicotyledonous seed that should be containing outermost covering, that is called as seed coat. Outermost covering called seed coat, and inside the seed coat presence of embryonic axis. In the case of seed coat, where there is occurrence of three regions in the case of dicot seeds, particularly in the case of seed coat, one of the region that is called as hilum region, raphe region, and micropyle. These are the regions which are confined, particularly in the case of seed coat of dicotyledonous seed. Structurally, suppose it is the bean seed. Outermost covering of the seed, it is called as seed coat. Here the seed coat is differentiated into two layers, testa and tegmen. Outermost layer of the seed coat, testa, and innermost seed coat, that is called as a tegmen. At the region of the seed coat, particularly above the middle portion of the seed, where there is the occurrence of microscopic aperture, that for the purpose of aeration, microscopic aperture, that is called as micropyle is present. And just into this micropyle, where there is occurrence of rigid region. That rigid region of the seed coat, that is called as raphe. Rigid region of the seed coat called raphe. And at the center region, or beneath to this raphe region, presence of a scab. It is the part the scarf part where what is that ovule is attached. The ovules which are developed into seed, in this portion, what is that ovule is attached, the funicle is attached. After the maturity of the ovule, the funicle is removed. Funicle is removed. It means the stalk of the ovule. The stalk of the ovule is joined to this particular this region after the maturity on a seed pod where there is a occurrence of scab. That scab that is called as hilum part. During its maturity, during its germination, it is the seed, outermost covering of the seed that is called as seed coat containing microbial region or rhabdoid region and hilum region. During its germination, where there is a formation of embryonic axis is separated, embryonic axis and formation of separation of cotyledons during its germination. Cotyledons. These are the fleshy parts of the seed. Fleshy parts of the seed that is called as cotyledons. Where where the reserve food material is present. Reserve food material. It is something that is called as embryonic axis. Embryonic axis. The embryonic axis terminates to produce the two appendages. One of the appendages that is called as plumule, and one more appendage that is called as a radical. Plumule and radical. In future, plumule is developed into. Plumule is the part of the embryo. The embryonic axis is terminates to produce two appendages. The one of the appendages is called as a plumule. Another appendage is called as a radical. In future, what is that? Plumule is developed into a shoot system. Plumule is developed into shoot system. Radical is developed into root system. It is about that dicotyledonous seed. Usually, majority of the dicotyledonous seeds during its maturity, endosperm is utilized. Such kind of seeds are called as non-endospermic or ex-albuminous seeds. It is about that of a dicotyledonous seed. Dicotyledonous seed. Come to next monocotyledonous seed. Monocotyledonous seed. Majority of that monocotyledonous seeds which are albuminous seeds. Albuminous are endospermic seeds. Majority of monocotyledonous seeds which are albuminous are endospermic seeds except archid. Archid is monocot. Archids which are the monocots. These archid seeds does not containing endosperm. Therefore, that is called as such kind of seeds are called as non-endospermic seed. The archid is the monocot, but in this archid seed, the endosperm is absent. Therefore, the name that is called as non-endospermic seeds. Best example for endospermic seeds are monocotyledonous seed, that is maize seed. Maize seed or maize grain. Maize seed or maize grain. That maize seed usually irregular flattened structure. That maize seed that should be containing two portions. The larger sized portion that is called as endosperm. And the smaller sized portion that is called as embryo. Smaller sized portion that is called as embryo with cotyledon. Around this seed, around the maize seed, presence of outermost layer, membranous layer. That membranous layer is called as seed coat. The seed coat is always binds with fruit wall. Fruit wall. Here the fruit wall is called as a pericarp. Pericarp is always binds to the seed coat of the maize seed. Then afterwards these two layers which are modified into membranous outermost covering of the seed. Next to that, presence of endosperm. Around the endosperm, occurrence of one of the proteinaceous layer. Proteinaceous layer is present around the endosperm. That proteinaceous layer that is called as aleurone layer. Aleurone layer is the proteinaceous layer that should be situated, that should be present around the massive endosperm. Around the massive endosperm, presence of a layer, that layer that is called as aleurone layer. And lower region of this seed, lower region of this grain, maize grain, presence of a small portion, that is small portion that should be consists of embryonal axis. It is the embryonal axis. It is towards the one side. Only one cotyledon is present. The cotyledon of a monocot seed, that is the one that is called as scutellum. Scutellum is the cotyledon, and it is the part that is called as the embryonal axis. That embryonal axis terminates into two appendages. One of the appendage that is called as plumule. Plumule is the appendage, and towards the lower end of the embryonal axis, occurrence of one more appendage. That appendage that is called as radicle. Especially in the case of monocots, the plumule is covered by a sheath. Plumule is covered by a sheath, especially in the case of monocots. Plumule is covered by a sheath. That sheath that is called as polyoctile. And like that of polyoctile, around the radicle, occurrence of one more sheath. That sheath protects the radicle. This sheath protects the plumule. Around the radicle, presence of a sheath, protective covering, protective sheath, that is called as polyorhiza. It is the structure of maize seed. The maize seed shows almost leathery layer that is called that should be modified from seed coat and fruit wall. Next to that, around the endosperm, presence of a proteinaceous layer. That proteinaceous layer is called as a aleurone layer. And beneath to this massive endosperm, presence of very smaller region of the grain or seed, that is called as embryonal axis and cotyledon. The cotyledon of monocot seed, that is called as scutellum. Here there is embryonal axis, terminates to produce plumule and radicals which are covered by a protective sheath, polyoctile and polyorhiza. It is the one that is called as maize seed.